This video is brought to you by us. Join the top 1% of PLC programmers. Learn from the world's best so you can join their rank. Head on over to realpars.com and start learning now. In this video, we're going to introduce you to a very common device used in process control today, the temperature transmitter. We'll discuss the sensors used with them and show you how they are connected in a typical control loop. We'll also give you an insight into how they are calibrated. Temperature transmitters are available in all different shapes and sizes, depending on the application and environment they are expected to operate. To name a few, there are DIN rail-mounted temperature transmitters, field-mounted temperature transmitters, and hockey puck-style temperature transmitters. Before we look at a temperature transmitter in detail, let's look at where it fits in a typical process control system. A temperature transmitter is a device that converts the signal produced by a temperature sensor into a standard instrumentation signal representing a process variable temperature being measured and controlled. The most common transmitter instrumentation output signal is 4 to 20 milliamps. The signal from the temperature transmitter is sent to a controller that determines what action is required and generates an appropriate output signal. Controllers are either a PLC or a DCS in process control today. The heating or cooling source exerts a direct influence on the process as directed by the controller. A temperature transmitter requires a power supply to operate. Most temperature transmitters are two-wire types having only two wires. These two wires provide power for the transmitter and are also the signal lines. A four-wire transmitter has two wires connected to a power supply and two signal wires connected to the PLC. The power supply can be AC or DC, depending on the vendor and model. We haven't said much about the temperature sensors, so let's do that now. The two most common temperature sensors used in process control are the thermocouple and the resistance temperature detector, or RTD. We've got lots of details on both of these devices in our other videos. Later, we'll tell you where you can find these videos. The thermocouple produces a change in voltage with a temperature change. Thermocouples have only two wires. An RTD produces a change in resistance with a temperature change. Unlike a thermocouple that has only two leads, an RTD can have 2, 3, or 4 leads. It's common to see temperature transmitters that are capable of working with either an RTD or a thermocouple. You may have heard the term digital temperature transmitter. This term has been around for a while now, and its meaning is evolving. Historically, a digital temperature transmitter was a smart transmitter. The smart transmitter is an intelligent transmitter that has an analog output of 4 to 20 milliamps and also provides digital communication signal information such as instrument tag names, calibration data, and sensor diagnostics. These smart transmitters use HART protocol or Foundation Field Bus or Profibus. As with any instrumentation transmitter, a temperature transmitter needs to be adjusted or calibrated so that the current output of 4 to 20 milliamps represents the temperature range of the process variable being measured. For example, a process variable temperature range of 0 degrees Celsius to 100 degrees Celsius will produce a current range of 4 to 20 milliamps. In every calibration scenario, the sensor is replaced by a device that can simulate the output of the sensor over the entire process variable temperature range. For a thermocouple, the sensor is replaced by a device that produces a range of millivolts. As you can imagine, it's not easy to create these small voltages. For an RTD, the sensor is replaced by a device that produces a range of resistances. Historically, the device that produced a range of resistances was a decade box. Today, we've got signal reference calibrators that can output a variety of electrical signals that can simulate RTDs and thermocouples, making it much easier to calibrate temperature transmitters. How are the actual adjustments performed? Older-style temperature transmitters have multi-turn potentiometer adjustments called zero and span. The zero pod is adjusted to produce 4 milliamps when the simulated temperature is 0%, and the span pod is adjusted to produce 20 milliamps when the simulated temperature is 100%. As an example, let's calibrate a temperature transmitter connected to a PT100 RTD, assuming a temperature range of 32 degrees Fahrenheit to 100 degrees Fahrenheit. We can get the resistance values at our calibration temperatures from a PT100 table. We will start with the zero calibration. As you can see in the calibration table, a PT100 RTD has a resistance of 100 ohms at 32 degrees Fahrenheit. So, we'll set 100 ohms on the decade box. The multimeter current should be adjusted to 4 milliamps by rotating the zero adjustment screw. For span calibration, we'll find the high range temperature on the table and set the corresponding resistance on the decade box. The multimeter current should be adjusted to 20 milliamps by rotating the span adjustment screw. Newer style temperature transmitters do not have external zero or span adjustments, but are programmed or calibrated using the software. The transmitter is connected to a computer via a serial USB connection. This video wouldn't be complete if we didn't talk about one of the newest trends in transmitters, the wireless transmitter. As the name implies, the transmitter does not send its signal to a receiver via wires. The signal is transmitted to a receiver via a Wi-Fi signal. Once the signal is received, it can be sent to a computer so readings can be saved and later printed or exported to a spreadsheet. Or, the received signal can be retransmitted via wires as a 4 to 20 milliamp signal to a PLC. To learn more about temperature sensors, you might want to review our videos called What is a Temperature Sensor? And PT100 Sensor Explained. You can find the link to these videos in the description. Let's review what we've discussed. Temperature transmitters are available in several different shapes and sizes. A temperature transmitter is a device that converts the signal produced by a temperature sensor into a standard instrumentation signal representing a process variable temperature being measured and controlled. The most common transmitter instrumentation output signal is 4 to 20 milliamps. Most temperature transmitters are two-wire types, having only two wires. The two most common temperature sensors used in process control are the thermocouple and the resistance temperature detector, or RTD. Many temperature transmitters are capable of working with either an RTD or a thermocouple. Signal reference calibrators can output a variety of electrical signals that can simulate RTDs and thermocouples, making it much easier to perform calibration. Older-style temperature transmitters have multi-turn potentiometer adjustments, called zero and span, used for calibration. Newer-style temperature transmitters are programmed or calibrated using the software. A wireless temperature transmitter sends signals to a receiver via a Wi-Fi signal. Want to learn PLC programming in an easy-to-understand format and take your career to the next level? Head on over to realpars.com.